All right. Ready to untangle the AI family tree?
Sounds fun.
We got some listener questions about how all the different types of AI are like related to each other.
Okay.
And especially they wanted to figure out the connection between LLMs,
hmm
NLP, and just machine learning in general.
Right.
So I think this deep dive is perfect for that. We're going to break it all down.
It really is like a puzzle, isn't it?
Yeah.
Figuring out how all these pieces fit together. But once you see that bigger picture, it really does start to click.
Okay, so let's start putting those puzzle pieces together.
Right.
Where do we even begin with this AI family tree?
Well, I think the roots of this tree, they really lie in machine learning, or ML for short.
Okay.
That's kind of the foundation
Mm.
for pretty much everything we're going to be talking about today.
Right.
Think of ML as like teaching computers to learn from data
Okay.
without having to program every single rule.
So instead of giving the computer a step-by-step recipe,
Yeah.
we're giving it ingredients and letting it figure out how to bake the cake.
Exactly. And that's where things get really, really interesting.
Mm-hmm.
See, one of the branches
Ah.
that grew from this, like ML trunk,
Yeah.
is natural language processing,
Mhm.
or NLP.
Okay.
It's all about teaching computers to understand and work with human language.
Ah, so this is where all the buzz about chatbots and LLMs comes in.
You got it. NLP is like the parent category,
Okay.
and it covers everything from simple tasks like spam filtering
Right.
to much more complex things like machine translation and, yes, those large language models that you mentioned.
Okay, so LLMs are like the star athletes of
Yeah.
the NLP family, getting all the attention for their impressive feats.
That's a great way to put it. But here's a key insight
Okay.
from the source material. LLMs are powerful, no doubt,
Mm-hmm.
but they're just one tool in the NLP toolbox.
Sure.
Sometimes the older traditional NLP methods that rely on carefully crafted rules and linguistic knowledge still actually outperform LLMs for specific tasks.
Wow, I hadn't thought of it that way. So it's like assuming a power drill is the best tool for every job,
Yeah.
when sometimes a good old-fashioned screwdriver works better.
Exactly. It all depends on what you're trying to do.
Yeah.
Now, thinking back to our AI family tree,
Uh-huh.
I'm guessing you're wondering what other branches sprouted
Yes.
from those machine learning roots besides NLP.
You read my mind. If NLP is just one branch, what else is growing on this AI tree?
Well, let's explore some of the other key branches.
Mm.
One that you've probably heard of is supervised learning.
Mm-hmm.
It's like teaching a dog new tricks, where you provide specific instructions and
Yeah.
rewards for good behavior.
Okay, so instead of letting the AI kind of learn on its own, like in unsupervised learning, we're giving it like labeled data and
Yeah.
clear goals.
Precisely. Think of it like predicting house prices. You feed the algorithm a bunch of data on house features and their corresponding prices,
Mm-hmm.
and it learns to predict the price of a new house
Right.
based on those features.
Yeah.
This is actually how companies personalize your shopping experience.
Interesting.
By analyzing your past purchases and browsing history, AI can predict what you're most likely to buy next.
So it's all about making predictions based on labeled examples.
Yes.
What about unsupervised learning? How does that work without a teacher giving it the answers?
Yeah, unsupervised learning is where things get a bit more mysterious.
Okay.
Instead of labeled data,
Hmm?
you give the algorithm a bunch of information and let it find patterns on its own.
So like grouping customers based on their purchasing behavior without having like predefined categories.
Yeah, that's where unsupervised learning shines.
So it's like letting the AI be a detective, sifting through evidence and uncovering hidden connections. That's pretty cool.
Absolutely.
Are there any other branches of AI that are as intriguing as this one?
Oh, there are so many.
Okay.
Another one that often captures people's imagination
Okay.
is reinforcement learning.
Mm-hmm.
This is where the AI learns by interacting with an environment
Okay.
and getting feedback, almost like learning by playing a game.
So it's like trial and error, but with a computer learning from its mistakes.
That's a great way to put it.
I can see how that would be powerful for things like robotics or self-driving cars.
Exactly. And then you've got things like deep learning,
Yeah.
which uses those incredibly complex neural networks
Right.
to model intricate patterns. Think of those layers like a chain of detectives, each specializing in a specific clue.
Mm-hmm.
The first layer might detect basic shapes, the next one recognizes objects,
Okay.
and the final layer identifies the whole scene.
Deep learning, neural networks, those are some pretty big buzzwords these days.
Absolutely.
But let's not get ahead of ourselves just yet.
Right.
Before we dive deeper into those, what other immediate branches should we add to our AI family tree?
Well, there's computer vision, which focuses on enabling computers to see and
Uh,
interpret images and videos.
So self-driving cars and facial recognition technology would fall under that?
Absolutely.
That's wild. What else?
We also have transfer learning, which involves using knowledge gained from one task
Okay.
to help solve a different but related one. Think of it like learning to ride a bike and then applying those skills to skateboarding.
So it's about leveraging existing
I
knowledge
guess.
to accelerate learning in new areas.
Hmm.
That's clever. And then there's anomaly detection, which helps identify those unusual events or outliers in
Yes.
data, like fraudulent transactions
Right.
or potential equipment failures. That sounds super useful
That's
for
it.
security and risk management.
Exactly. Time series analysis is another one, and it deals with analyzing data points collected over time,
Okay.
like stock prices or weather patterns. And finally, we can't forget recommender systems,
Yeah.
which are those algorithms that suggest products, movies, or music based on your past preferences.
Wow, that's a lot of branches.
It is quite a few.
And I have a feeling we've only just scratched the surface of this AI forest.
Oh, absolutely. There's so much more to explore.
Speaking of exploring, I noticed something kind of interesting in the source material.
Go.
It mentioned drug discovery
Right.
using AI, which seemed like a surprising connection at first.
Yeah.
How does that even work?
Ah, yes. That's where things get really interesting. What's fascinating here is that drug discovery isn't just using one branch of AI.
Oh.
It's actually leveraging the power of many of them working together.
Hold on, so you're telling me AI isn't just writing poems. It's actually designing life-saving medicines.
It is. It's not magic,
That's wild.
but it's pretty close.
Okay, I'm hooked. Tell me more about how these different AI branches are teaming up to tackle something as complex as drug discovery.
Well, for starters, think about supervised learning.
Mm-hmm.
We can train an algorithm on existing data about drug molecules and their properties, teaching it to predict whether a new molecule is likely to be effective against a certain disease.
So it's using past knowledge to make educated guesses about the future of medicine.
Yeah, I like that.
What about unsupervised learning? How does that fit into this equation?
Well, unsupervised learning is amazing for finding hidden patterns
Okay.
in massive data sets of chemical structures. It can help identify potential drug candidates that might have been overlooked
Interesting.
by traditional methods.
So it's like having an AI research assistant
Yes.
that can spot promising leads that human scientists might miss.
Exactly. And then there's deep learning,
Right.
which is crucial for more complex tasks like predicting how a drug will interact with specific proteins in the body,
Wow.
or even designing entirely new molecules
Okay.
with desired properties.
This is blowing my mind. So it's not just one AI superhero saving the day.
Right.
It's a whole team of AI specialists working together.
Precisely. And this really highlights the key takeaway here. It's not just about one technique or algorithm,
Yeah.
but rather how different branches of AI can be combined and integrated to tackle
Yeah.
some of humanity's biggest problems.
This is truly remarkable. I'm starting to see the bigger picture now, and it's far more intricate and interconnected
Yeah.
than I ever imagined.
It is. It's pretty amazing
Yeah.
when you think about it.
And we'll be right back after a quick break to continue our exploration of this amazing world of AI. Welcome back. I'm ready to dive even deeper into these AI branches, especially deep learning.
Okay.
It's been popping up everywhere lately.
Yeah.
And I'm curious to kind of go beyond the buzzwords and really understand how it works.
Great question. Deep learning is fascinating
Yeah.
because it's inspired by how our own brains work.
Okay.
Imagine a network of interconnected nodes, kind of like neurons,
Right.
working together to process information. That's essentially what a deep neural network is.
So these artificial neurons are organized in layers.
Yes.
And that's where the deep learning comes from.
Exactly. Each layer learns to extract different features from the data.
Okay.
It's like having a team of specialists, each one focusing on a specific aspect of the problem.
Right.
The first layer might identify basic shapes.
Mm-hmm.
The next one recognizes patterns and so on, building up to more and more complex representations.
Okay, that makes sense. But why is having all these layers so important?
Right.
What's the advantage of this, like, deep architecture?
The magic really lies in this hierarchical learning process.
Okay.
Each layer builds upon the knowledge of the previous one, creating a more sophisticated understanding of the data.
So deep learning is all about learning complex patterns and
Yes,
representations from data. And this hierarchical structure is what makes it so powerful.
precisely. And the beauty of it
Yeah.
is that these networks can learn to perform incredibly complex tasks
Okay.
without being explicitly programmed every step of the way.
Right.
We just feed them a ton of data,
Right.
and they figure out the patterns and the rules on their own.
That's mind-blowing. It's almost like they're developing their own form of intelligence.
It is pretty amazing.
No wonder deep learning is behind so many of the recent breakthroughs in AI.
Right.
Like those incredible image recognition systems
Yeah.
and those chatbots that can hold actual conversations.
It certainly is. And it's not just limited to things like image recognition and natural language processing.
Oh,
Deep learning is being applied in all sorts of fields,
okay.
from healthcare to finance to robotics.
Wow.
It's truly a transformative technology
Yeah.
with seemingly endless potential.
Speaking of transformative, what about transfer learning?
Yes.
We touched on it earlier, and I'm curious to hear more about how it's being used in the real world.
Transfer learning is all about efficiency
Okay.
and leveraging existing knowledge.
Right.
Imagine you've already trained a deep learning model to recognize different types of flowers.
Okay.
With transfer learning, you could take that pre-trained model and fine-tune it to recognize different types of trees instead.
So instead of starting from scratch each time,
Exactly.
you're giving the model a head start. That sounds incredibly efficient,
It is.
especially when you consider all the time and resources required to train these complex models.
Exactly. It's like giving the model a crash course based on its previous experience.
Mm-hmm.
And this is particularly useful when you have limited data for the new task.
Right.
By transferring knowledge from a larger related data set, you can often achieve much better performance
Okay.
with much less training time.
This makes me think about all the different ways these AI models are being trained.
Yeah,
It's almost like there's a whole spectrum of AI learning styles, just like with humans.
that's a great analogy.
Yeah.
And just like with human learning,
Right.
there are different approaches to training AI models.
Okay.
Supervised learning is like having a teacher
Mm-hmm.
guide the model, providing clear instructions and feedback.
Right.
Unsupervised learning, on the other hand, is more like letting the model explore the world independently,
Yep.
discovering patterns without any explicit guidance.
So supervised learning is structured and goal-oriented,
Uh-huh.
while unsupervised learning is more exploratory and open-ended.
Precisely. Each approach has its strengths and weaknesses,
Okay.
and the best choice often depends on the specific task at hand and the available data.
Mm-hmm.
Sometimes you might even combine different approaches to create a hybrid learning strategy.
This is really helping me appreciate all the nuances of AI
Yeah,
and how much thought and strategy go into training these models. It's not just about throwing data at a computer and hoping for the best.
absolutely not. There's a real art to
Mm.
designing and training AI models effectively.
Yeah.
And one of the most fascinating aspects of this field is that it's constantly evolving. New techniques and algorithms are being developed all the time, pushing the boundaries of what's possible.
Speaking of pushing boundaries, I can't help but think back to our conversation about drug discovery using AI. It's incredible to think that these algorithms are actually helping to design new medicines that could potentially save lives.
It's a remarkable feat, and it's just one example of how AI is being applied to solve
Right.
some of humanity's most pressing challenges,
Mm-hmm.
from personalized medicine to climate change mitigation to sustainable agriculture. AI is poised to revolutionize countless industries and aspects of our lives.
It's both exciting and a little daunting
Yeah.
to think about the potential impact of AI. It feels like we're on the cusp of a new era
Right.
where these intelligent machines will play an increasingly significant role in shaping our future.
Yeah. It's an interesting time for sure.
But enough about the future for now.
Okay.
Let's bring it back to the present
Right.
and explore some of the other branches we discussed earlier, like computer vision and anomaly detection. What are some of the real-world applications of these technologies?
Well, computer vision is already having a huge impact on our lives.
Okay.
It's behind the facial recognition systems used in our smartphones, the self-driving cars being tested on our roads, and the medical imaging technology that helps doctors diagnose diseases earlier and more accurately.
Wow. So computer vision is literally giving machines the ability to see and interpret the world around them, much like we do. That's
Yeah.
incredible.
It is.
And what about anomaly detection? Where is that being applied?
Anomaly detection is proving to be invaluable in a wide range of industries.
Okay.
It's used in cybersecurity to detect suspicious activity on networks,
Right.
in finance to flag fraudulent transactions,
Mm-hmm.
and in manufacturing to identify defects in products before they reach consumers.
It sounds like anomaly detection is all about finding those needles in the haystack,
Yeah.
those rare events that could signal something important. It's like having an AI watchdog
Right.
that's always on the lookout for anything out of the ordinary.
Exactly. And it's particularly useful in situations where traditional rule-based systems might struggle
Right.
to keep up with the complexity and volume of data. By leveraging machine learning algorithms, anomaly detection systems can learn to identify patterns and deviations that might otherwise go unnoticed.
This is really opening my eyes to the sheer breadth and depth of AI.
Yeah.
It's not just about robots and science fiction anymore. It's a fundamental technology
It really is.
that's already transforming our world in countless ways.
Absolutely.
But before we get too carried away exploring all these individual branches,
Right.
I'd love to hear your take on how this all fits together.
Okay.
What are some of the key takeaways from our exploration of the AI family tree so far?
It's been quite a journey, hasn't it? We've gone from the roots of machine learning to the branches of NLP, deep learning, transfer learning, and so much more. I think the most important takeaway is that AI is not a monolithic entity.
Okay.
It's a diverse ecosystem of
Yeah.
approaches and techniques,
Yeah.
each with its own strengths and limitations.
Mm-hmm.
And the real magic happens when we start combining these different approaches to tackle complex problems.
That's a great point. It's not about finding the one AI to rule them all,
Right,
but
exactly.
rather about understanding the strengths of each approach and how they can work together to achieve a common goal.
Exactly. And I think it's important to remember that AI is still in its early stages of development. We're just beginning to scratch the surface of its potential.
I'm excited to see what the future holds, but before we get lost in speculation,
Okay.
let's take a moment to reflect on what we've learned so far
Mm.
and prepare for the final part of our deep dive into the world of AI. Welcome back. We've explored the AI family tree, learned about some of its most fascinating branches, and even seen how AI is being used to tackle real-world challenges like drug discovery. Now I'm ready to hear your thoughts on what's next for this incredible technology.
It really is amazing to think about how far AI has come in just a few short years. From basic algorithms to complex neural networks, we've witnessed an explosion of innovation in this field. And it's only going to get more exciting from here.
That's what I'm really curious about, the future of AI. What are some of the areas where you see AI having the biggest impact in the years to come?
Well, one area that holds immense potential is personalized medicine.
Okay.
Imagine a world where treatments are tailored to your individual genetic makeup, lifestyle, and environmental factors.
Wow.
It's like having a medical plan designed specifically for you, optimizing your health and well-being.
Wow, that's incredible. This sounds like something out of a sci-fi movie, but it seems like AI could actually make it a reality. What role would AI play in this personalized medicine revolution?
Well, AI could analyze massive amounts of data, from your genetic code to your medical history to even your daily habits,
Okay.
to identify patterns and predict your risk for certain diseases. This would allow doctors to intervene early and develop personalized prevention strategies.
So it's about moving from a one-size-fits-all approach to healthcare to a more targeted and individualized model. That's pretty revolutionary. What other areas are you excited about?
Another area that's particularly fascinating is the application of AI in climate change mitigation. We're facing unprecedented challenges when it comes to our environment, and AI can play a crucial role in helping us find solutions.
You're right. This is a global issue that needs all the brainpower we can get, human and artificial. How exactly could AI contribute to tackling climate change?
Well, AI could be used to analyze climate data, identify trends, and predict future scenarios. This would give us valuable insights to make informed decisions about resource management, energy consumption, and emissions reduction.
So it's like having an AI advisor helping us to make smarter decisions about how to protect our planet. What other climate-related tasks could AI tackle?
AI could also play a role in developing new technologies for carbon capture and storage or optimizing renewable energy systems.
Yeah.
Imagine AI-powered smart grids that efficiently distribute energy from solar and wind power, reducing our reliance on fossil fuels.
It's inspiring to see how AI could be harnessed to address some of the most pressing issues facing humanity. It sounds like we're on the verge of a technological revolution that could truly change the world for the better.
It's certainly an exciting time to be working in this field, and while we've only just begun to explore the possibilities, it's clear that AI has the potential to make a profound impact on our lives and the future of our planet.
I completely agree. As we wrap up this deep dive, I want to thank you for sharing your expertise and insights. It's been an incredible journey exploring the AI family tree from its roots to its branches and beyond. And to our listeners, we encourage you to continue exploring the world of AI. Who knows, maybe you'll be the one developing the next groundbreaking AI application. Thanks for joining us on this deep dive into the world of AI.